Good morning, students. Today we are going to see the chemistry second volume, chemical bonding. This lesson already you studied. Already last link we taught you till the Lewis dot structure. Okay. Now we are going to see the formal charge. Okay. Formal charge. It is in formal charges in second volume, chemical bonding. Okay. Now you take the book and take that lesson, chemical bonding, and take this page number 76, formal charge. Okay. Shall we go inside it? Okay, ma. Now we are going to see the formal charge. First, we are going to draw the Lewis structure for the carbon dioxide. And for them, some steps are there. First, you should draw the skeletal structure. That is O, C, and O. Then you have to find out the total number of valence electron in carbon dioxide. And for carbon, 4 electrons are there, and for oxygen, 6 electrons are there. So 1 into 4 for carbon and 2 into 6 for oxygen. So if you are multiplying, you will get the number as 16. Now you have to draw the single bond between the atoms. 2 bonds can be drawn. In the below the figure, it is given 2 bonds are drawn between carbon and oxygen, which occurs for 4 electrons. Now distribute the remaining electrons. That is, previously we calculated 16 electrons. From that 16 electrons, we should subtract the 4 number. Why? Because you draw 2 bonds, and those 2 bonds are for each bond is each bond is formed by 2 electrons. So you have to subtract 4 number from there. So you will get 12 as 6 lone pairs starting from most electronegative atom, that is the oxygen. 6 lone pairs are distributed to the 2 terminal oxygen, 3 each to satisfy their octet. Octal means 8 electrons in the outermost. Verify whether all the atoms have the octet configuration. In the above distribution, the central carbon atom have 2 pairs, and it is for octet. 2 pairs of electrons are there, and it is need nearly 2 more electrons for the octet rule. To satisfy the octet rule, 2 lone pairs of 1 oxygen or 1 pair from each oxygen can be moved to form the multiple bond, leading the formation of 2 possible structures for carbon dioxide, that is given in the tabular column or in the box. That is oxygen with the 4 electrons, double bond, carbon, double bond, then oxygen again 4. That is the first structure, and one more structure is also possible, that oxygen triple bond with the 2 electrons, and carbon single bond oxygen with 6 electrons. So both 2 structures are possible for it. The 2 possible. Similarly, the Lewis structure for many molecules are drawn using the above steps, given more than one acceptable structure. Now let us consider the above mentioned 2 structures of carbon dioxide, in which one of the above forms represents the best distribution of electrons in the molecule. To find an answer, we need to know the formal charge. That only now we are going to find out. Listen carefully. Formal charge of an atom in a molecule is an electrical charge difference between the valence electron in an isolated atom and the number of electrons assigned to the atom in the Lewis structure. And formal charge of an atom, we have one formula, that is nothing but NV minus NL plus NB by 2. Here NV is the number of valence electron of the atom in its isolated state. Next, NL is the number of electrons present as lone pair around the atom in the Lewis structure. And NB is the number of electrons present in bonds around the bond, that is bond pairs in the Lewis structure. Now let us calculate the formal charge of all the atoms in both the structures. For first structure 1, for formal charge on carbon, the formula is Nb minus Nl plus Nb by 2. Here the valence electron for carbon is 4 minus, here there is no lone pair, every electrons are paired, So then lone pair of electron is 0 plus bonded pairs are 8 by 2. So you will get the formal charge on the oxygen. So you will get 8 by 2 is nothing but 4. 4 minus 4 is 0. So the formal charge of the carbon is 0. And formal charge on oxygen, like the same, we have to use the formula. Nv, that is valence electron of oxygen, is 6 minus Nl, lone pair of electrons are 4 plus 4 by 2. 4 by 2 means you will get 2. So 4 plus 2 is 6. 6 minus 6 is 0 for both the oxygen, because both oxygen have the same structure. And for the second structure, the formal charge on carbon is again the same formula, Nv minus Nl plus Nv by 2. 4 minus 0 plus 8 by 2, which is equal to 0. The formal charge on a singly bonded oxygen as a 6 minus a 6 plus 2 by 2, which is equal to minus 1. And the formal charge on the triply bonded oxygen as a 6 minus 2 plus 6 by 2, which is equal to plus 1. So the structures, for the structures, carbon double bond, oxygen double bond carbon, double bond oxygen, for them all the oxygen as well as the carbon atom get the 0 as its formal charge. And in the next structure, oxygen triple bond carbon single bond oxygen, for that the oxygen which is having triple bond have the formal charge plus 1 and carbon again 0, and the oxygen which is having the single bond get the formal charges minus 1. After calculating the formal charges, the best representation of Lewis structure can be selected by using the guidelines given here. The first point is the structure in which all the formal charges are 0 preferred over the one with the charge. That is the first point. Then the second point is a structure with a small formal charge is preferred over with the one with the higher formal charge. And the third point is a structure in which a negative formal charge are placed on the most electronegative atom is preferred. Now, in the case of carbon dioxide structure, the structure 1 is preferred over the structure 2 as it has 0 formal charges for all atoms. Next is Lewis structure for the exception to octet rule. Some of the atoms or some of the molecules are not having the octet rule, and for that how the Lewis structure is framed. The octet rule is used for writing Lewis structure for molecules with the second period elements as central atoms. In such molecule, the central atom have less than 8 electrons around them, while some other have more than 8 electrons. Exception to the octet rule can be categorized into the following 3 types. Some of them, சிலதுக்கு என்ன இருக்கும் 8 எலக்ட்ரான் இருக்கும், சிலதுக்கு 8க்கு குறைவா இருக்கும், சிலது 8க்கு மேல இருக்கும். அப்போ அந்த 8 இருக்கிறத மட்டும் விட்டுட்டு 8க்கு குறைவா இருக்கிறதும் 8க்கு மேல இருக்கிறதுக்கும் எப்படி நம்ம Lewis dot structure எழுதுறோம்ன்றதுக்கு 3 rules இருக்கு. That is molecules with electron deficiency as central atoms, then molecules containing odd electrons, molecules with the expanded valence shells. First we are going to see the molecules with the electron deficient central atom. For that we are taking the example as boron trifluoride as an example. The central atom is boron, which is having only 3 valence electrons. So each fluorine has 7 electrons. The Lewis structure is F, which is having 6 electrons around it, and all the 3 F having 6 electrons around it, and 1 is in the bond formation. And in the above structure, only 6 electrons around the boron atom. If you are considering boron atom, boron சுத்தி எத்தனை இருக்கு? வெறும் 6 electrons இருக்கும். Moving a lone pair from one of the fluorine to form an additional bond that is given in the next picture. F single bond B, single bond F, and double bond F. Another one is linked with double bond, but which is having only 4 electrons. மீதிக்கெல்லாம் 6 electron, இதுக்கு மட்டும் 4 electron தான் இருக்கும். However, the above structure is unfavorable as the most electronegative atom fluorine shows positive formal charge, and hence the structure with incomplete octet is favorable one. Molecules such as BCl3, BeCl2, that is boron trichloride, beryllium dichloride, etc. also have the incomplete octet. So இதே மாதிரியே போரான் ட்ரைக்ளோரைடும் பெரிலியம் டைக்ளோரைடுக்கும் இன்கம்ப்ளீட் ஆக்டெட் கான்ஃபிகரேஷன் தான் இருக்கும். Next, molecules containing odd electrons. A few molecules have the central atom with an odd number of valence electrons. For example, in nitrogen dioxide and nitric oxide, all the atoms does not have the octet configuration. The Lewis structure of the above molecule are shown in the picture. That is N double bond O. Both the nitrogen as well as oxygen formal charge is 0, and the next one nitrogen dioxide O double bond N single bond O, and oxygen which is having double bond is 0 formal charge, and a nitrogen which is having a lone pair of lone single electron plus 1 acid formal charge, and oxygen which is 6 electrons around it which is having minus acids formal charge. Then Lewis structure of nitric oxide and the nitrogen dioxide, Lewis structure is given there with the formal charge. Next, molecules with the expanded valence shells. In a molecule such as sulfur hexafluoride, that is SF6, phosphorus pentachloride PCl5, the central atom has more than 8 valence electron. But sulfur hexafluoride phosphorus pentachloride எடுத்துட்டீங்கன்னா அதுல 8 எலக்ட்ரானோட அதிகமா இருக்கும். Here the central atom can accommodate additional electron pairs by using the outer vacant d orbital. In SF6, the central atom sulfur is surrounded by 6 bonding pair of electrons or 12 electrons. கீழே PCl5 SF6 கொடுத்துருக்கு பாருங்க. P அதுல 5 தான் இருக்கும் உங்களுக்கு. அதை சுத்தி எத்தனை இருக்கு? 5 chlorine, but the chlorine is having the octet configuration, whereas phosphorus க்கு 10 electron வந்துரும். அதே மாதிரி சல்ஃபர் ஹெக்ஸாஃப்ளூரைடு எடுத்துட்டீங்கனாலும் ஃப்ளூரினுக்கு எல்லாருக்குமே 8 இருக்கும். ஆனா சல்ஃபருக்கு மட்டும் ஒரு பாண்டும் 2ன்னு எடுத்துக்கிட்டீங்கன்னா 2, 4, 6, 8, 10, 12 எலக்ட்ரான்ஸ் இருக்கும். சரிங்களா? இங்க ஒரு இவாலுவேட் யுவர் செல்ஃப் கொடுக்க பாருங்க. ஃபார்மல் சார்ஜ் ஆஃப் கார்பனைல் குளோரைடு COCl2, இந்த கார்பனைல் குளோரைடோடைய ஃபார்மல் சார்ஜ் ஒன்னுக்கு கார்பன் ஆக்சிஜன் குளோரின், இந்த 3க்கு என்ன செய்யணும்? ஃபார்மல் சார்ஜ் கண்டுபிடிங்க. இது உங்களுக்கு செல்ஃப் இவாலுவேஷன் கொஸ்டின். இது என்ன செய்யணும்? நீங்களா போட்டு பார்க்கணும். போட்டு பார்த்தீங்கன்னா தான் உங்களுக்கு ஆன்சர் தெரியும். தெரியலையானா நாளைய கிளாஸ்ல மறுபடியும் வந்து பார்த்துக்கலாம். ஓகேவா? நெக்ஸ்ட் we will pass on the types of bonds, ionic or electrovalent bond. When the electronegativity difference between the two combining atoms is large, the least electronegative atom completely transfer one or more of its valence electron to the other combining atom, so that both the atoms can attain the nearest inert gas configuration. The complete transfer of electron leads to the formation of a cation and an anion. Both these ions are held together by the electrostatic force, which is known as ionic bond. So, in order to get the octet rule வர்றதுக்காக ஒரு சில ஆட்டம் என்ன செய்யும்? ஒரு எலக்ட்ரானை கொடுத்தோ இல்ல ஒரு எலக்ட்ரானை வாங்கியோ என்ன செய்யும்? பாண்ட் 8 அதோடைய கான்ஃபிகரேஷனை மாத்திக்கும். Suppose if it is donating an electron, it becomes cation. If it accepts an electron, it becomes anion. So cation anion ஃபார்ம் ஆகும்போது அதுக்கு ரெண்டுக்கும் இடையில ஒரு எலக்ட்ரோஸ்டாட்டிக் ஃபோர்ஸ் இருக்கும். அதனால ஒரு பாண்ட் வருதுன்னா that bond is called as ionic bond. Now let us consider the formation of potassium chloride. The electronic configuration of potassium and chlorine are: potassium is argon configuration with the 4s1 and chlorine is neon configuration with the 3s2 3p5. Potassium has only 1 electron in its valence shell and chlorine has 7 electron in its valence shell. By losing 1 electron, potassium attain the inert gas configuration. Potassium அந்த ஒரு எலக்ட்ரானை கொடுத்துருச்சுன்னா அது inert configuration இருக்கும். I like the same. If the chlorine is accepting that electron, that too also get the stable configuration, that is octet. The two ions combine to form an ionic crystal in which they are held together by electrostatic force. The energy required for the formation of 1 mole of K plus is 418.81 kilojoules, that is ionization energy, and the energy released during the formation of 1 mole of chloride ion is minus 348.56 kilojoules, that is called as electron gain enthalpy. The sum of these two energies is positive, that is 70.25 kilojoules. However, during the formation of 1 mole of potassium chloride, crystal from its constituent ions, that is 718 kilojoules energy is released. This favors the formation of potassium chloride and it stabilizes. Next type of bond is coordinate covalent bond. The formation of covalent, both the combining atoms contribute one electron each, and these electrons are mutually shared among them. However, in certain bond formation, one of the combining atom donates a pair of electron, that is two electrons which are necessary for the covalent bond formation, and these two electrons are shared by both the combining atoms. These type of bonds are called coordinate covalent bond or simply covalent bond. அதாவது ஒரு எலக்ட்ரான் என்ன செய்யும், சப்போஸ் அதுல என்ன செய்யாது, ஒரு எலக்ட்ரானை டொனேட்டும் பண்ணாது அக்செப்டும் பண்ணாது, பட் ரெண்டு மாலிகுல் ரெண்டு ஆட்டம் என்ன செய்யும், மியூச்சுவலா ஷேர் பண்ணிக்கும். அந்த மாதிரி மியூச்சுவலா ஷேர் பண்ணினா வர்றது வந்து கோவலன்ட் கோஆர்டினேட் பாண்டு. சப்போஸ் இஃப் டூ எலக்ட்ரான்ஸ் ஆர் தேர் அண்ட் தோஸ் ஆர் டூ எலக்ட்ரான்ஸ் என்ன செய்யும், ஒரே ஒரு ஆட்டமே அதுக்கு டொனேட் பண்ணுச்சுனாக்கா அதுக்கு பேரு கோஆர்டினேட் பாண்ட். The combining atom which donates the pair of electron is called a donor atom, and the other atom an acceptor atom. The bond is denoted by an arrow. இந்த coordinate bondல ரெண்டு எலக்ட்ரான் எது கொடுக்குதோ அதுக்கு பேரு டோனார் ஆட்டம், எது அந்த ரெண்டு எலக்ட்ரான் அக்செப்ட் பண்ணிக்குதோ அதுக்கு பேரு அக்செப்டார். அப்ப அது மென்ஷன் பண்றதுக்கு ஒரு பாண்ட் போட்டு என்ன செய்வாங்க, ஆரோ மார்க் போட்டிருப்பாங்க. Later in coordination bond we will refer the donor atom as the ligand and the acceptor as the central metal atom. And further அதுக்கப்புறம் என்ன செய்தாங்கன்னா இந்த டோனார் ஆட்டத்தை வந்து என்ன செய்றாங்க, லிகாண்ட்னும் அக்செப்டாரு மெட்டல் சென்ட்ரல் மெட்டல் அயானும் சொன்னாங்க. ஃபார் எக்ஸாம்பிள் இன் ferrocyanide ion FeCN6 4-, each cyanide ion that is Cs minus donates a pair of electrons to form a coordinate bond with the ion that is Fe2+, and these electrons are shared by Fe2+ and cyanide. And the structure is given here. இந்த ஸ்ட்ரக்சர்ல பாருங்க எல்லாமே cyanide வந்து arrow markல கொடுத்திருக்கு. That means cyanide தான இருக்கு, ரெண்டு எலக்ட்ரானை Fe க்கு கொடுக்குதுன்னு அர்த்தம். Next is the structure of ferrocyanide ion. In certain cases, molecules having a lone pair of electrons such as ammonia donates its pair to one electron deficient molecule such as a BF3 to form a coordinate bond. இது BF3 NH3ல BF3ல வந்து என்ன இருக்கும், டோட்டலா 3 எலக்ட்ரான் தான் இருக்கும், 3 எலக்ட்ரான் பாண்ட் ஃபார்மேஷன்ல வந்துருது. பட் அம்மோனியால பாத்தீங்கன்னா நைட்ரஜனுக்கு 5 எலக்ட்ரான் இருக்கு, அதுல 3 மட்டும் பாண்ட் ஃபார்மேஷன்ல, 2 தான் பாண்ட் ஃபார்மேஷன்ல லோன் பேரா இருக்கும். அந்த லோன் பேர் ஆஃப் எலக்ட்ரான் இஸ் டொனேட்டட் டு boron trifluoride. So that is in between BF3 and NH3 also we have the coordinate bond. Okay, next we are going to see the bond parameters. A covalent bond is characteristic by a parameter such as bond length, bond angle, bond order, etc. A brief description of such bond parameters are given here. That is bond length, bond order, and then a bond angle. Those are all about those things we are going to see now. First is bond length. The distance between a nuclei of two covalently bonded atoms is called bond length. ரெண்டு கோவலண்டா பாண்டான ரெண்டுனா மியூச்சுவல் ஷேரா, அந்த மியூச்சுவல் ஷேர் பண்ணி பாண்ட் ஃபார்ம் பண்ற ரெண்டு ஆட்டமுடைய நியூக்ளியஸ்க்கு இடையில இருக்க டிஸ்டன்ஸ் பேர் தான் bond length. Consider the covalent molecule AB. The bond length is given by the sum of the radii of the bonded atom, that is Ra plus Rb. The length of a bond can be determined by spectroscopy, X-ray diffraction, and electron diffraction techniques. The bond length depends on the size of the atom and the number of bonds, that is multiplicity bond also between the combining atoms. Greater the size of the atom, greater will be the bond length. Size of the atom என்ன இருக்கும், பெருசா இருந்துச்சுன்னா அந்த ஆட்டம் உடைய bond length பெருசா இருக்கும். And for example, carbon-carbon single bond length is 1.54 angstrom, that is longer than carbon-nitrogen single bond length, that is 1.43. Increase in number of bonds between the two atoms decreases the bond length. For example, carbon-carbon single bond that is longer than carbon-carbon double bond, which the length is 1.33 angstrom, and carbon-carbon triple bond length is 1.20. That means single bond is longer, double bond is little bit shorter, and triple bond is more than shorter. Next is bond order. The number of bonds formed between two bonded atoms in the molecule is called bond order. In Lewis theory, the bond order is equal to the number of shared pair of electrons between two bonded atoms. For example, in nitrogen molecule, there is only one shared pair of electron and hence the bond order is 1. Similarly, in water and HCl and methane, etc., the central atom forms single bond with a bond order of 1. Now, in this tabular column, some of the molecules name as well as their bonded atoms and bond order is given. Hydrogen bond order is 1, that is single bond. Oxygen bond order is 2, that means in between oxygen and oxygen we have double bond. Nitrogen bond order is 3, that means nitrogen ஒரு nitrogen இன்னொரு nitrogen இடையில triple bond இருக்குதுன்னு அர்த்தம். அதனால தான் அதோட bond order 3. Okay, and for HCN, H க்கும் C க்கும் இருக்கிறது single bond தான், but C க்கும் N க்கும் இருக்கிறது triple bond. So CN உடைய bond order வந்து 3. Like the same, formaldehyde, methane and ethene are given here. Okay, next we are going to see the next parameter, that is bond angle. Covalent bonds are directional in nature and are oriented in the specific direction in space. This directional nature creates a fixed angle between the two covalent bonds in a molecule, and this angle is termed as bond angle. It is usually expressed in degree. That is, the bond angle can be determined by the spectroscopic method and it can give some idea about the shape of the molecule. Here it is given. For methane, the bond angle between HCH is 109.9 degrees and 28 minutes, and ammonia, the H and H bond angle is 107 degree and 18 minutes, and for water, the HOH bond angle is 104 degree and 35 minutes. Next, we are going to see the bond enthalpy. Bond enthalpy is defined as the minimum amount of energy required to break 1 mole of a particular bond in a molecule in the gaseous state. That is, the unit of bond enthalpy is kJ per mole. Larger the bond enthalpy, stronger will be the bond. The bond energy value depends on the size of the atom and number of the bonds between the bonded atoms. Larger the size of the atom involved in the bond, lesser is the bond enthalpy. In case of polyatomic molecules with 2 or more same bond types, in the term of average bond enthalpy is used. For such bonds, the arithmetic mean of the bond energy value of the same type of the bond is considered as average bond enthalpy. For example, in water, there are 2 OH bonds present and the energy needed to break them are not the same. 2 OH bond இருக்கும், அந்த OH bond break பண்றதுக்கு ரெண்டுக்குமே ஒரே எனர்ஜி ஒரே எனர்ஜி இருக்காது. For example, water gaseous stateல இருந்துச்சுன்னா H plus OH minus the delta H, the enthalpy value is 502 kilojoules per mole. அதே OH இருக்குதுன்னா அதுல Hயும் Oயும் break பண்ற பாண்டுக்கு எடுத்துக்கிற enthalpy value 427 kilojoules per mole. So we have to consider the average of the enthalpy of OH. So 502 plus 427 and divided by 2. So you will get the answer as 464.5 kilojoules per mole. That is the bond enthalpy of water molecule. Next, in this tabular column, some of the bond types are given as well as its bond enthalpy is also given in kilojoules as well as its bond length is given there. Okay. Next, we will see the resonance. Resonance is one of the important topic of it. When we write Lewis structure for a molecule, more than one valid Lewis structure are possible in certain. Here in this one, the skeletal structure of this one is, the skeletal structure of this is oxygen atoms are denoted as OA, OB and OC, and OA, OB, OC are around the carbon atom. The total valence electrons is 1 into X, 1 into 4 that is for carbon plus 3 into 6 for oxygen plus 2 that is the charge, which is equal to 24 electrons. Then the distribution of the valence electron gives the following structure: carbon and around those carbonate, they have the single bond, completing the octet for the carbon by moving one lone pair of electron from one of the oxygen OA and write the charge of the ion to as on the upper side as shown in the figure. And here in this figure, ஒரு ஆக்சிஜன்ல இருக்கிற OAன்ற ஆக்சிஜன்ல இருந்து ஒரு லோன் பேர் ஆஃப் எலக்ட்ரானை கார்பனுக்கு டொனேட் பண்ணி அந்த இடத்துல ஒரு டபுள் பாண்ட் கொடுக்குறோம். Then in case we can draw two additional structure also like the same by moving the lone pair from the other two oxygen. மீதி ரெண்டு ஆக்சிஜன்ல இருந்தும் அதே மாதிரி ரெண்டு எலக்ட்ரான் எடுத்து என்ன செய்யலாம், வேற வேற இடத்துல OB ல இருந்து OC ல இருந்து எடுத்து ரெண்டு டபுள் பாண்ட் போடலாம். So we are creating three similar structure as shown below, in which the relative position of the atoms are the same. இங்க அதோட பொசிஷன் வந்து அதேதான், but they only differ in the position of bonding the lone pair of electron. Such structures are called resonance structure, and also they are called as canonical structure, and this phenomena is called as resonance. Here the resonance structure of carbonate ion is given. Next, it is evident from the experimental result that all the carbon oxygen bonds in carbonate ion are equivalent. The actual structure of the molecule is said to be resonance hybrid, and average of these three resonance forms it is an important to note that the carbonate ion does not change from one structure to another structure and vice versa. It is not possible to picturize the resonance hybrid by drawing a single Lewis structure. இது ஒரு single Lewis structure வச்சு நம்ம explain பண்ண முடியாது. However, the following structures gives a qualitative idea about the correct structure. So இங்க ஒரு ஸ்ட்ரக்சர் கொடுத்திருக்காங்க பாருங்க. இந்த ஸ்ட்ரக்சர்ல கார்பன் கார்பன் சிங்கிள் பாண்ட் மட்டும் கொடுத்துட்டாங்க. அடுத்தது இன்னொரு பாண்ட் டாட்டர்ல ப்ளூ கலர்ல கொடுத்திருக்காங்க. சோ ஆக்சிஜனுடைய பாண்ட் ஆர்டர் -2/3 -2/3 இருக்குது. சரிங்களா? It is found that the energy of the resonance hybrid is given in structure force is lower than that all the possible canonical structures, that is structure 1 and 2 and 3. The difference in the energy between 1 or 2 or 3, the most stable canonical structure, and structure 4 is the resonance hybrid, that is called as resonance energy. And here you have to draw the resonance structure for the ozone molecule and nitrous oxide N2O. இதே மாதிரி என்ன செய்றீங்க, அது ரெண்டுக்கும் resonance structure எழுதி பார்க்கறீங்க. சரிங்களா? Next is polarity of bond. The partial ionic character in covalent bond, that is when a covalent bond is formed between two identical atoms, that is hydrogen, oxygen and fluorine, both the atoms have an equal tendency to attract the shared pair of electron, and hence the shared pair of electrons lies exactly in the middle of the nuclei of the two atoms. ரெண்டுமே ஒண்ணா எடுக்கும்போது அந்த ரெண்டு எலக்ட்ரான் என்ன ஆகும், actually those are present in the middle of those two atoms. However, in the case of covalent bonds formed between two atoms having different electronegativities, the atom with the higher electronegativity will have the greater tendency to attract the shared pair of electrons, and it moves towards itself than the other atom. As a result, a cloud of shared pair gets distorted. Now let us consider the covalent bond between the hydrogen and fluorine in hydrogen fluoride. The electronegativities of hydrogen and fluorine according to the Pauling scale is 2.1 and 4. It means fluorine attracts the shared pair of electrons approximately twice as much of the hydrogen, which leads in the partial negative charge on fluorine and partial positive charge on hydrogen. Hence, H of bond is said to be polar covalent bond. இப்ப ரெண்டு ஆட்டம் இருக்குதுன்னா ரெண்டு ஆட்டம்னா சேர்க்க இடையில ஒரு பாண்ட் வர்றதுக்கு ரெண்டு எலக்ட்ரானு, அதுல எது வந்து அதிகமா எலக்ட்ரோ நெகட்டிவிட்டியா இருக்குதோ அந்த ஷேர்ட் பேட் ஆஃப் எலக்ட்ரான் என்ன செய்யும், அது தாம் பக்கமா இழுத்துக்கும். அதே மாதிரி இங்க fluorine வந்து தாம் பக்கமா என்ன செய்யிருக்கு, அந்த ஷேர்ட் பேர் ஆஃப் எலக்ட்ரான் அது பக்கமா அது இழுத்துக்குது. அது பக்கமா இழுத்துக்கிறதால fluorine சுத்தி எலக்ட்ரான் கிளவுடு அதிகமா இருக்கும். அதனால fluorine மைனஸ் சார்ஜும் ஹைட்ரஜன் எலக்ட்ரான் சார்ஜ் இல்லாதால அதுக்கிட்ட பிளஸ் சார்ஜும் கிடைக்குது. இந்த மாதிரி உங்களுக்கு பார்ஷியலா பிளஸ் சார்ஜும் மைனஸ் சார்ஜும் கிடைக்கிறதுக்கு பேர் தான் போலார் கோவலன்ட் பாண்ட். Here a very small equal and opposite charges are separated by a small distance, that is 91 picometer, and it is represented to us as dipole. Next we are going to see another one parameter, that is dipole moment. The polarity of a covalent bond can be measured in terms of dipole moment, which is defined as mu is equal to q into 2d. where mu is the dipole moment and q is the charge and 2d is the distance between the two charges. The dipole moment is a vector quantity and the direction of the dipole moment of vector points from the negative charge to the positive charge. The unit of the dipole moment is coulomb meter, that is mentioned as cm. It is usually expressed in d by unit, which is mentioned by, which is having the symbol as capital D. The conversion factor is 1 d by is equal to 3.336 into 10 power minus 30 cm. Cm is coulomb meter. Diatomic molecules such as hydrogen, oxygen, and fluorine, etc., have zero dipole moment and are called as non-polar molecules. And the molecules such as HF, hydrogen fluoride, hydrogen chloride, carbon monoxide, and nitrogen oxide, those all have non-zero dipole moments, and those are called as polar molecules. Molecules having the polar bonds will not necessarily have a dipole moment. For example, the linear form of carbon dioxide, which is also having the zero dipole moment. Even though it has two polar bonds, and in carbon dioxide, the dipole moment of two polar bonds, that is carbon monoxide, are equal to magnitude, but both of them are in the opposite direction. Hence, the net dipole moment of carbon dioxide is 0. That is mu is equal to mu1 plus mu2. Mu1 plus mu2 is nothing but the negative of mu1. So that is minus mu1. So both they get cancelled and we will get the value as 0 there. In case of water, the net dipole moment is a vector sum of mu1 plus mu2, and that is given in the diagram. The dipole moment of the water is found to be 1.85 d. And here some of the dipole moments of the common molecules are given. For HF it is 1.91 and HCl 1.03, water it is 1.85 and ammonia 1.47 and CHCl3, that is chloroform, it is 1.01. Next, the extent of the ionic character in a covalent bond can be related to the electronegativity difference to the bonded atoms. In a typical polar molecule, A, fractionally you have the negative charge bond, and B with the fractional positive charge. The electronegativity difference is nothing but Xa minus Xb can be used to predict the percentage of the ionic character. If the electronegativity difference is, that is Xa minus Xb is equal to 1.7, then the bond AB is 50% of ionic character. If it is greater than 1.7, then the bond is, then the bond between A and B has more than 50% ionic character. And if it is less than 1.7, then the bond between A and B is less than 50% of ionic character. Here one more evaluate yourself is given. In this one, OCS and CS2, two molecules are given and you have to find out which has the higher dipole moment value and what is the reason for that. Okay, so with that I plan to finish the lesson, and the remaining we will see in our class and in the next class. Okay, student, now I am giving you, followed by this one, I am giving you the question and answer in the form of a PDF, and you have to take it and you have to write it in your assignment notebook. Okay, ma? Thank you, children.